The smoke was still rising from USS Yorktown's ruptured hull when Lieutenant Commander Takeshi Yamamoto lowered his binoculars and allowed himself a rare smile. From his position aboard the Japanese carrier Zuikaku, 8,000 meters away across the Coral Sea, he had watched the American carrier absorb punishment that should have sent her to the bottom. A 551-pound armor-piercing bomb had penetrated her flight deck, exploded deep within her hull, and created carnage across 5 deck levels. Yamamoto, a naval engineer before the war and now an intelligence officer with the combined fleet, began his damage assessment with the methodical precision that Japanese naval doctrine demanded. "The carrier is finished," he reported to his commander. "Observing heavy list to port, visible fire damage, speed reduced to what appears to be 6 knots maximum. By our calculations, she will require a minimum of 90 days in a major shipyard facility for repair. She is eliminated from combat operations for the remainder of 1942. His commander nodded with satisfaction. "Signal Fleet Headquarters. 1 American fleet carrier neutralized. They will not have her for the Midway operation." Yamamoto returned to his observation post and watched Yorktown limp away toward the horizon, trailing oil and leaving a smoke plume visible for 20 miles. He felt the professional satisfaction of an engineer who had seen his calculations confirmed by reality. The bomb had struck in the optimal location, near the uptakes that vented exhaust from the boiler rooms, causing maximum disruption to the engineering plant. The explosion had destroyed machinery, ruptured fuel tanks, killed dozens of men, and created structural damage that would take months to repair properly. What Yamamoto could not see, what no Japanese observer could see, was what was happening inside that damaged carrier. While Yorktown appeared to be crawling away at a pathetic 6 knots, her actual speed was 20 knots. Captain Elliot Buckmaster, her commanding officer, had ordered damage control teams to create a massive smoke screen from the damaged areas to disguise their actual capabilities. The oil slick that looked so catastrophic was mostly seawater, mixed with a small amount of fuel oil, deliberately pumped overboard to enhance the illusion of mortal damage. Below decks, Chief Carpenter Boyd Mackenzie ignored every page of the damage control manual he had memorized during peacetime. The manual said, "Assess damage completely, shore bulkheads properly, wait for dry dock before attempting structural repairs." Mackenzie, a 42-year-old former shipyard worker from Philadelphia, looked at the twisted metal, the ruptured compartments, the destroyed machinery, and thought, "We don't have time for by-the-book repairs. Make it work, make it fast, make it fight." He grabbed a welding torch and started cutting away the most damaged steel, not to replace it. There was no time for that, but to clear access so he could weld thick steel plates over the holes. It was ugly. It violated every principle of proper ship repair, but it was functional. Within 6 hours of taking the bomb hit, Mackenzie's damage control teams had sealed the worst breaches, shored up weakened bulkheads with timber beams cannibalized from packing crates, and jury-rigged pumps to handle flooding. In the engineering spaces, Lieutenant Commander John Greenbacker faced his own crisis. The bomb had wrecked the No. 2 elevator machinery and damaged 3 of Yorktown's 8 boilers. Proper repair would require cutting away damaged piping, installing new boiler tubes, rebuilding control systems. Greenbacker, who had worked in his father's machine shop in Ohio before attending Annapolis, took one look at the damage and made a decision that would have horrified his instructors at engineering school. "Isolate the damaged boilers," he ordered. "Don't try to repair them, just shut them down and reroute steam from the working units. Bypass every safety system that's not absolutely critical. I want maximum steam to the turbines using whatever boilers we have left operational." His chief engineer stared at him. "Sir, that's going to put tremendous strain on the remaining boilers. We'll be operating well above design specifications. We could have a catastrophic failure. We'll have a catastrophic failure for certain if we can't make speed and the Japanese come back to finish us off. Make it work, Chief. I don't care how ugly it is. The 3,300-mile journey from the Coral Sea to Pearl Harbor became a testament to American damage control philosophy. While Yorktown maintained 20 knots, a speed that Japanese intelligence would have considered impossible for a ship in her reported condition, her crew performed repair miracles that would have seemed like fantasy to engineers trained in the rigid doctrines of the Imperial Japanese Navy. Machinist's mate James Sullivan, a 24-year-old from Boston, spent 48 hours straight in the machine shop fabricating replacement parts for damaged equipment. When he couldn't find the proper materials, he improvised. A broken valve was replaced with one cannibalized from a different system and modified with a file and hammer to fit. A shattered gear was recreated by hand-carving a pattern in wood, pouring molten metal from mess hall pots into the improvised mold, then grinding the rough casting into an approximation of the original part. "It's not pretty," Sullivan told his supervisor, "but it'll work. Maybe not forever, but long enough." That phrase, long enough, became the operational philosophy. Not perfect repairs, not permanent solutions, but functional fixes that would keep the ship fighting until the next battle was won. Meanwhile, in Tokyo, Lieutenant Commander Yamamoto's damage assessment reached the desk of Admiral Isoroku Yamamoto, no relation, commander of the combined fleet. The admiral studied the report with satisfaction. The Americans now had only 2 operational carriers in the Pacific, Enterprise and Hornet. The Midway operation, scheduled for early June, would face limited opposition. Victory was assured. But the Japanese intelligence system, for all its sophistication, had made a fundamental error in understanding American capabilities. They had assumed that American shipyards and repair facilities operated according to the same principles as Japanese ones: meticulous, hierarchical, bound by procedure and protocol. They could not conceive of a system that valued speed over perfection, function over form, improvisation over doctrine. Yorktown arrived at Pearl Harbor on May 27, 1942, at 1 p.m. Rear Admiral Aubrey Fitch, who had been aboard during the Coral Sea battle and had witnessed the damage firsthand, had already cabled his assessment to Admiral Chester Nimitz. 90 days minimum required for battle readiness. Recommend routing to Puget Sound Naval Shipyard for complete reconstruction. 90 days. 3 months. The Midway operation was scheduled for June 4th, just 8 days away. By every standard of naval engineering, Yorktown could not possibly participate in that battle. She would be in dry dock when the Japanese struck, unavailable when she was needed most. Admiral Nimitz stood on the dock as Yorktown approached, studying the damage through binoculars. He could see the patched holes in her hull, the smoke stains around her uptakes, the visible sag in her flight deck where internal structure had been weakened. Any other officer would have looked at that damage and agreed with Fitch's assessment. 90 days minimum. But Nimitz had spent the last 6 months watching Pearl Harbor's workforce perform miracles. The battleship sunk on December 7th had been written off as total losses. Yet, Arizona aside, every one of them had been raised, patched, and either returned to service or stripped for parts. The workers who had achieved those impossible salvages had learned to think in terms of hours, not months. They had learned that impossible just meant difficult and dangerous. Nimitz met with his repair officers within an hour of Yorktown's arrival. How long to make her battle ready? The head of the repair facility consulted his notes. Admiral, with all due respect, we can't make her battle ready. We can make her float and steam, but she'll need months of proper repair work to— I don't need proper repairs, Nimitz interrupted. I need her to launch and recover aircraft. I need her to make 25 knots. I need her to fight. How long?" The officers exchanged glances. One of them, a lieutenant commander named Thomas Hughes, who had supervised the salvage of USS California, spoke carefully. "If we ignore standard procedures, if we accept that the repairs will be temporary and possibly dangerous, if we're willing to just patch and jury-rig rather than do proper reconstruction, maybe 72 hours, 3 days. But Admiral, she'll be held together with spit and prayers. She could fall apart in heavy seas." "Heavy seas are the least of her worries," Nimitz replied. "Get her ready in 72 hours. I don't care what you have to do." Yorktown entered Dry Dock No. 1 at 8 p.m. on May 27th. Before the dock had fully drained, before the water even stopped swirling around the ship's damaged hull, 400 workers swarmed aboard. They came from every shop on the base: welders, electricians, ship fitters, machinists, pipe fitters, sheet metal workers. Many had worked through the night on other ships. They would work for the next 72 hours straight. Master Chief Patrick O'Malley, a 53-year-old veteran of the Great War who had been repairing ships since 1917, stood at the edge of the dry dock and tried to make sense of the damage. The 551-pound bomb had created a zone of destruction that extended from the flight deck down through 5 levels. Frames were twisted, decks were buckled, machinery was destroyed. By peacetime standards, this carrier needed to be cut apart and rebuilt. "We ain't got peacetime," O'Malley muttered to himself. He turned to the crowd of workers gathering around him. "Listen up. We got 3 days to make this lady fight. That means we don't do proper repairs. We do fast repairs. See a hole? Weld a plate over it. See damaged structure? Shore it up with timbers and move on. See destroyed machinery. If we can't fix it in an hour, we bypass it. We're not rebuilding this ship. We're putting a Band-Aid on her and sending her back to war. Questions?" A young welder raised his hand. "Chief, what about proper structural analysis? What about stress calculations? What about winning the goddamn war?" O'Malley interrupted. "Son, the Japanese are coming to Midway in 8 days with 4 fleet carriers. We got 2. If we can make this one ready, we got 3. That might be enough to win. If we sit here doing stress calculations while they sink Midway and then come for Hawaii, it won't matter how pretty our repair work is. Now grab your torch and start welding." The repair work that followed would have horrified any traditional naval architect. It defied doctrine, violated procedures, and ignored nearly every established principle of proper shipyard practice. It was also absolutely necessary. The bomb damage zone became the focus of around-the-clock attention. Instead of cutting away all the damaged structure and rebuilding it properly, a process that would take weeks, the workers simply welded massive steel plates over everything. Fractured frames were left in place and reinforced with plates welded directly to the damaged metal. Buckled decks were jacked back into rough alignment and covered with patches. The result looked like a metal patchwork quilt, ugly and brutal. But it would hold. Electrician Lewis Walters, 21 years old and fresh from trade school, found himself running cables in ways that would have gotten him failed in any licensing exam. Instead of running wiring through proper conduits and junction boxes, he simply strung cables along the overhead, across decks, through hatches. When he ran out of proper marine-grade wire, he used automotive wire. When he ran out of that, he spliced together different gauges and types, creating electrical connections that made experienced electricians wince. "This is all wrong," he told his supervisor. "These connections aren't watertight. The wire gauges don't match. The circuit protection is inadequate. This whole system could short out or catch fire." His supervisor, a man who had rewired half the Pacific Fleet over the last 6 months, just shrugged. "Will it work for 3 weeks?" "Probably, maybe. I don't know. Then make it work. We'll fix it properly after the battle. The fuel tank repairs presented their own challenge. Near misses from Japanese bombs had ruptured fuel tanks along 30 frames of the ship's hull. Standard procedure called for draining all fuel, cleaning the tanks, inspecting for damage, cutting away ruptured sections, welding in replacement plating, pressure testing, and refilling. Time required, 2 weeks minimum. Chief Petty Officer Antonio Garcia, a 38-year-old Hispanic welder from San Diego, looked at the damaged tanks and made a decision that violated every safety regulation in the Navy. "We're not draining and cleaning. We're patching the holes with the fuel still in the tanks." His assistant stared at him. "Chief, that's insane. We'll be welding next to thousands of gallons of aviation fuel. One spark in the wrong place and we blow the whole aft section of the ship." "Then don't let a spark get in the wrong place," Garcia replied. "We got safety protocols. We got fire watches. We got CO2 suppression systems. We use them all, we work careful, and we get this done in 18 hours instead of 2 weeks. The next 18 hours tested every nerve in Garcia's body. He and his team welded patches over ruptured fuel tanks, while millions of gallons of volatile aviation gasoline sloshed just inches away. Every torch cut, every welding arc, every spark was a potential catastrophe. But Garcia had learned something in 6 months of emergency repairs. Calculated risks were different from reckless chances. If you controlled every variable you could control, monitored everything continuously, and never relaxed for a second, you could perform operations that seemed suicidal and make them merely dangerous. They patched 27 fuel tanks without incident. The repairs were crude, plates welded over holes, with the damaged tank sections left in place. But they held pressure. Yorktown wouldn't be able to refuel at sea through some of her systems, and her total fuel capacity was reduced by 15%. But she could steam and fight. The boiler repairs tested the ingenuity of Pearl Harbor's engineers. 3 of Yorktown's 8 boilers had been damaged by the bomb blast, not destroyed, but damaged enough that proper repair would require removing them entirely and rebuilding them in a shop. Senior Chief Machinist's mate Robert Kowalski, who had maintained boilers for 25 years, studied the damage and made another decision that violated procedure. "We're not repairing the boilers," he announced. "We're going to bypass them entirely, isolate them from the steam system, seal the connections, reroute everything through the 5 good boilers. We'll lose some efficiency, and she won't make her full rated speed, but she'll make enough to fight." The work required cutting into the ship's steam systems, installing temporary piping, and creating connections that would have failed any inspection. But Kowalski's team had learned that temporary repairs could work if you understood the stresses and limitations. The key was not making something that would last forever, just making something that would last long enough. Throughout the 72 hours, the workers developed what would later be called combat repair doctrine, a completely different philosophy from peacetime shipyard practice. Instead of fixing things properly, they asked, "What's the minimum repair that will restore function?" Instead of worrying about longevity, they focused on immediate capability. Instead of following procedures, they solved problems. The continuous welding drew so much electrical power that it caused rolling blackouts across Oahu. Hospitals lost power and had to use emergency generators. Street lights went dark. Residential areas experienced hours without electricity. The civilian population accepted these disruptions without complaint. Everyone in Hawaii understood what was happening in Dry Dock No. 1. They understood that somewhere in the Pacific the Japanese were coming, and every hour of welding might be an hour that saved the islands from invasion. When the yard needed lumber to shore up damaged bulkheads, construction companies delivered truckloads without paperwork or payment. When workers needed specialized tools, machine shops opened at midnight to fabricate them. When someone needed food or coffee or a moment's rest, volunteers appeared with whatever was required. Pearl Harbor had transformed from a peacetime naval base into something unprecedented, a forward repair base operating at the edge of possibility, where the line between impossible and merely difficult disappeared entirely. On the second night, an incident occurred that would be retold for decades. A young welder named Michael Chen, working in one of the damaged compartments, had been on his feet for 36 hours straight. Exhaustion finally overcame him, and he fell asleep leaning against a bulkhead, his welding torch still in his hand. A supervisor found him, gently took the torch, and without waking him, simply welded around him. Chen woke 2 hours later to find he had been incorporated into the repair as a living brace, his body weight helping to hold a damaged frame in place while welding occurred around him. "Why didn't you wake me?" he asked the supervisor. "You looked like you needed the sleep," the supervisor replied, "and you were useful where you were." Throughout these 72 hours, Japanese intelligence continued to track Yorktown's movements. Their network of spies and observers in Hawaii reported the carrier's arrival, her entry into dry dock, the swarms of workers aboard her. But the analysts who received these reports applied Japanese standards to interpret them. A Japanese carrier in Yorktown's condition would require 90 days minimum for repair. This was not an estimate. It was a known fact, backed by decades of engineering practice and naval doctrine. Therefore, regardless of what appeared to be happening in Pearl Harbor, Yorktown could not possibly be ready for combat before late August at the earliest. The reports of intensive repair work were acknowledged but dismissed. The Americans were probably just stabilizing the ship, performing emergency repairs to make her safe for the long journey to a West Coast shipyard. In Tokyo, Lieutenant Commander Takeshi Yamamoto received these intelligence summaries and nodded with satisfaction. His damage assessment had been confirmed. Yorktown was out of action. The Midway operation would face only 2 American carriers, and Japanese numerical superiority was assured. On the morning of May 30th, 72 hours and 15 minutes after entering Dry Dock No. 1, USS Yorktown was flooded out of the dock. She didn't look like the ship that had entered. Her hull was covered with welded patches, visible where paint hadn't been applied. Cables ran along her decks in ways that violated every electrical code. Wooden beams shored up internal structure that should have been steel. Her fuel capacity was reduced, her speed was limited, her structural integrity was compromised. But she could fight. Captain Buckmaster stood on the bridge as tugs pulled his carrier away from the dock. He had watched the repair work with a combination of awe and terror. Every professional instinct told him that his ship was a floating disaster waiting to happen. The repairs violated so many principles of proper naval engineering that he couldn't count them all. By any rational standard, Yorktown should go directly to Puget Sound for complete reconstruction. But rational standards had been suspended on December 7, 1941. Buckmaster knew what his orders were. Take Yorktown to sea, steam to a position northwest of Midway, and engage 4 Japanese fleet carriers with whatever forces Admiral Nimitz could assemble. The fact that his ship had been repaired in 3 days instead of 3 months didn't change the mission. It made the mission possible. As Yorktown cleared Pearl Harbor and turned north, something else was happening that neither American nor Japanese intelligence fully appreciated. The 1,400 workers who had performed the 72-hour miracle weren't finished. They were already moving to the next ship, the next repair, the next impossible deadline. Pearl Harbor had become a machine for converting damaged warships back into fighting vessels, operating on principles that traditional naval engineering had never contemplated. On June 4, 1942, at 10:20 a.m., Lieutenant Commander Clarence McCluskey leading a formation of dive bombers from USS Enterprise, spotted the Japanese carrier fleet northeast of Midway. 4 fleet carriers steaming in perfect formation, Akagi, Kaga, Soryu, and Hiryu. The most powerful carrier force ever assembled, preparing to launch strikes that would destroy Midway's defences and open the way for invasion. What happened in the next 5 minutes changed the course of the Pacific War. McCluskey's bombers dove on Akagi and Kaga, while simultaneously bombers from Yorktown, the carrier that Japanese intelligence had confirmed was out of action, the ship that couldn't possibly be at Midway, attacked Soryu. The Japanese had planned for facing 2 American carriers. They had not planned for 3. They had not prepared for the possibility that a ship they had damaged at Coral Sea, a ship their engineers had calculated would need 90 days of repair, could appear at Midway just 5 weeks later. Aboard the Japanese flagship, Admiral Chuichi Nagumo received the radio report. Enemy dive bombers attacking from 3 carriers. Repeat, 3 carriers. Akagi hit, Kaga hit, Soryu hit, and burning. 3 carriers, Nagumo's staff officer said. That's impossible. Intelligence confirmed Yorktown was eliminated at Coral Sea. We damaged her too severely for rapid repair. But the bombs falling from Yorktown's aircraft were entirely possible and entirely real. Within 5 minutes, 3 of the 4 Japanese carriers were burning wrecks. By the end of the day, all 4 would be sunk or sinking. The Imperial Japanese Navy's supremacy in the Pacific was broken, destroyed in part by a carrier that Japanese engineers had calculated couldn't possibly be there. In the weeks after Midway, Japanese naval intelligence conducted an intensive investigation into how Yorktown had appeared at the battle. They obtained reconnaissance photographs of Pearl Harbor, spy reports, intercepted communications. They calculated repair times, analyzed damage assessments, consulted with their own naval engineers. The conclusion was unanimous and baffling. By Japanese standards, the repairs were impossible. A carrier with Yorktown's level of damage required a minimum of 90 days in a major naval shipyard with complete facilities. This wasn't an opinion or an estimate. It was a known fact, confirmed by decades of naval construction and repair experience. The Americans had somehow accomplished in 72 hours what Japanese doctrine said required 90 days. Several theories were proposed. 1. The damage at Coral Sea had been less severe than originally assessed. 2. The Americans had discovered revolutionary new repair techniques. 3. Pearl Harbor possessed facilities and equipment unknown to Japanese intelligence. 4. The carrier at Midway wasn't actually Yorktown, but a different ship in a deception operation. All of these theories were investigated. Coral Sea damage assessments were reviewed and confirmed. The damage had been as severe as originally reported. American repair techniques were analyzed through captured documents and interrogated prisoners. No revolutionary methods were found. Pearl Harbor's facilities were mapped through intelligence collection. Nothing special was discovered, and identity of the carrier at Midway was confirmed through multiple sources. It was definitely Yorktown. The Japanese engineers eventually concluded that American repair doctrine must operate on fundamentally different principles than their own. But they couldn't identify what those principles were, because the differences weren't technical, they were philosophical. Japanese naval repair doctrine was based on returning a ship to its original condition. Damage was to be completely corrected, systems were to be restored to design specifications, every repair was to meet peacetime standards. This approach guaranteed quality and longevity. It also guaranteed that major repairs took months. American combat repair doctrine, developed through desperate necessity after Pearl Harbor, was based on a single question: will it work long enough to fight? If the answer was yes, then the repair was acceptable, regardless of whether it was pretty, permanent, or compliant with peacetime standards. Function trumped form. Speed trumped perfection. Getting a ship back into the fight trumped everything else. This philosophical difference extended beyond just repair techniques. It reflected fundamentally different approaches to engineering, manufacturing, and warfare. Japanese industry emphasized craftsmanship, quality, and precision. American industry emphasized scale, speed, and pragmatic problem-solving. When those two philosophies collided at Midway, the result was 4 Japanese carriers on the bottom of the Pacific and a patched-together American carrier that had accomplished the impossible by refusing to accept that it was impossible. The workers who had performed Yorktown's 72-hour miracle remained largely anonymous. Master Chief O'Malley went back to supervising other repairs. Electrician Lewis Walters continued stringing cables in ways that violated every code. Chief Garcia kept welding next to fuel tanks full of volatile gasoline. They didn't receive medals or commendations. They simply moved to the next ship, the next repair, the next impossible deadline. Yorktown herself didn't survive the Battle of Midway. On June 4th, she was hit by Japanese aircraft and damaged again. On June 6th, a Japanese submarine torpedoed her while she was under tow. She finally sank on June 7, 1942, taking with her the 72 hours of repair work that had made her appearance at Midway possible. But in those 3 days of combat between her Pearl Harbor repairs and her final sinking, Yorktown's aircraft sank the Japanese carrier Soryu, damaged Hiryu, and contributed to the overall American victory that turned the tide of the Pacific War. The return on investment for 72 hours of welding, patching, and jury rigging was incalculable. Years after the war, in 1958, a symposium on naval engineering was held in Tokyo. Among the attendees was retired Admiral Takeshi Yamamoto, now a professor of naval architecture. During a session on damage control, an American presenter described the Yorktown repairs. Yamamoto listened with growing amazement as details were revealed. The welding over fuel tanks, the jury-rigged electrical systems, the structural patches that violated every principle of proper repair. During the question period, Yamamoto stood and asked, "You describe repairs that by any standard of naval engineering should have failed. The structural patches should have torn loose in heavy seas. The electrical systems should have short-circuited. The jury-rigged machinery should have broken down. How did these repairs not only hold together, but allow the ship to conduct combat operations?" The American presenter, a retired Navy commander who had supervised some of those repairs, thought about the question. "I think the answer is that we didn't know they should fail. We weren't thinking about what couldn't be done. We were only thinking about what had to be done. Maybe that made the difference." Yamamoto nodded slowly. "In Japanese we have a saying, 'The nail that sticks up gets hammered down.' It discourages improvisation and deviation from established procedure. Perhaps in war, the nail that sticks up is exactly what's needed." The story of Yorktown's 72-hour resurrection became legendary in naval circles, but its true significance went beyond just one ship's repair. It demonstrated that in modern warfare, industrial capacity and the willingness to challenge conventional thinking could be as decisive as tactics or technology. The Japanese had built the most perfect carriers in the world, maintained them to exacting standards, operated them with precision and skill. The Americans patched together damaged ships with welds and prayers and sent them back into battle. Both approaches had merit. But in the crucible of the Pacific War, American pragmatism proved more valuable than Japanese perfectionism. A perfect carrier under construction wasn't as useful as a patched carrier at sea. A beautifully engineered repair that took 3 months wasn't as valuable as an ugly repair that took 3 days. The Japanese never fully understood this. Even after Midway, even after the tide had turned against them, Japanese naval repair facilities continued to prioritize quality over speed, perfection over function. American carriers damaged in combat were back at sea in weeks. Japanese carriers with similar damage were in dock for months. The mathematical result was inevitable. America's effective carrier strength kept increasing while Japan's kept decreasing, even when actual construction and combat losses were fairly even. By 1945, the philosophical differences that had mystified Japanese engineers at Midway had compounded into overwhelming American naval superiority. Fast repair meant more ships available for combat. More ships available for combat meant more pressure on Japanese forces. More pressure meant more Japanese ships damaged. More damaged Japanese ships meant fewer available for combat, while they underwent their meticulous, time-consuming repairs. The cycle was self-reinforcing and ultimately fatal. Pearl Harbor's Dry Dock No. 1, where Yorktown's impossible repair had occurred, continued operating throughout the war. Thousands of ships passed through it, each receiving the same pragmatic, get-it-done-fast approach that had characterized that 72-hour miracle in May 1942. The workers who had performed that first impossible task trained others in their methods. Combat repair doctrine became official Navy policy. Today, a plaque at Pearl Harbor Naval Shipyard marks Dry Dock No. 1. It reads, "Here, in 72 hours during May 1942, Pearl Harbor Naval Shipyard workers performed emergency repairs on USS Yorktown, CV-5, that allowed her to participate in the Battle of Midway. Their work demonstrated that American industrial capability and innovative thinking could overcome any obstacle." Though Yorktown was lost at Midway, her presence there contributed to a decisive American victory that changed the course of the Pacific War. What the plaque doesn't mention is the deeper lesson, that sometimes the impossible becomes possible not through superior technology or revolutionary technique, but simply through the refusal to accept that something can't be done. The workers who repaired Yorktown in 72 hours weren't superhuman. They used ordinary tools, conventional materials, and standard repair methods. What made them extraordinary was their willingness to challenge the assumption that proper repairs required months. They asked, "What's the minimum work needed to make this ship fight?" And then they did that work, regardless of whether it met peacetime standards or violated established procedures. Japanese engineers couldn't understand how Yorktown was repaired so quickly because they were asking the wrong question. They kept trying to understand the technical methods, when the real answer was philosophical. The Americans hadn't discovered faster welding techniques or superior materials. They had simply rejected the premise that repair speed was bounded by peacetime standards. Once that premise was rejected, once the goal became make it work rather than make it perfect, repair times compressed from months to days. This same pattern appeared throughout American industrial mobilization during World War II. The Liberty ships that were supposed to take months to build were launched in weeks. The factories that were supposed to need years to retool for war production were converted in months. The training programs that were supposed to require extended periods were compressed into intensive courses. Again and again, American industry asked, "How fast can we do this?" instead of, "How fast should we do this?" And the results consistently shocked observers who were bound by conventional thinking. The Japanese, despite their many strengths, never fully made this mental shift. Their engineers remained bound by peacetime standards. Their factories continued to prioritize quality over quantity. Their training programs maintained traditional timelines. The result was technically superior equipment produced in insufficient quantities, too slowly to replace combat losses. When Robert Ballard discovered Yorktown's wreck in 1998, Lying 16 to 650 feet below the Pacific surface, the Pearl Harbor repairs were still visible. The welded plates, the patched holes, the jury-rigged fixes that got her to Midway, all preserved in the deep, cold water. Those ugly repairs, which violated every principle of proper naval architecture, had accomplished something that perfectly proper repairs could never have achieved. They had put a wounded carrier back in combat, in time to help win the most important battle of the Pacific War. The lesson resonates far beyond naval history. In any field, there's tension between doing things properly and doing things quickly, between following established procedure and improvising solutions, between waiting for perfect conditions and acting with what you have. Yorktown's 72-hour resurrection demonstrated that sometimes speed and pragmatism beat perfection and procedure, that temporary fixes can have permanent impact, that impossible is just a word people use before someone proves them wrong. Japanese engineers asked, "How can American repair a carrier in 72 hours when our calculations prove it takes 90 days?" The answer they never fully grasped was simple. The Americans didn't try to do it the right way. They just tried to do it the fast way. And in war, fast often beats right. The shipyard workers who achieved this feat went back to their jobs when the war ended. Most lived ordinary lives, their extraordinary accomplishment known only to those who studied naval history closely. But they had demonstrated something profound, that ordinary people, given urgent purpose and freedom from conventional constraints, can achieve extraordinary things. They had proven that American industrial might wasn't just about factories and resources. It was about a mindset that refused to accept limitations. When modern U.S. Navy damage control teams train, they study Yorktown's 72-hour repair as a case study, not for the specific techniques, which have been superseded by better technology, but for the philosophy. Focus on mission restoration, not perfect restoration. Accept temporary solutions if they work. Challenge assumptions about what's possible. Don't let procedural perfection be the enemy of functional adequacy. And sometimes, in those training sessions, an instructor will tell students about the mystified Japanese engineers who couldn't understand how Americans did the impossible. The instructor explains that the Japanese were trying to find a secret, some hidden technology or revolutionary method. But there was no secret. There was just a different question. Instead of asking, "How do we restore this ship to perfect condition?" the Americans asked, "How do we make this ship fight?" The first question led to 90 days of meticulous repair. The second led to 72 hours of brutal pragmatism. And in May 1942, with the fate of the Pacific War hanging in the balance, brutal pragmatism was exactly what was needed.